Start this sheet backwards. I'm going to start with equilateral and work our way back up to the top, okay? So an equilateral triangle, if you notice from your classification chart, okay, where did you put both equilateral triangles? Under equilateral and equiangular, okay? That is a fact, okay? That is a theorem. It says when you have an equilateral triangle, it has to be equiangular, okay? Now I'm going to write this as an if-then statement because that's how we've been writing our theorem so far. Equilateral, equiangular, okay? If a triangle has three congruent sides, then it has three congruent angles. Okay. The converse of this does work. So if you have three congruent angles, you have three congruent sides. So the second you know it's equilateral, you know it's equiangular. The second you know it's equiangular, you know it's an equilateral, okay? Not only that, but you also know every measurement. All angles have to measure. If they're all congruent, they all measure what? 60. Yes. Because 180 divided by 3 is, and that's never going to change. So technically speaking, this theorem comes from your isosceles triangle theorem, but this one's super obvious to you. That's why I started with it, okay? So now let's spring up to that top box, okay? So the isosceles triangle theorem, okay? Very much the same idea here. So when you can identify three congruent sides, you can immediately identify three congruent angles. It does work with isosceles as well, but with an isosceles triangle, you're identifying two congruent sides. So then you will be able to identify two congruent angles, okay? So it kind of like they go with each other, right? Nope. Yep. Two congruent sides, okay? Two congruent angles. Now, there is a specific location of the angles, okay? The angles are specified in reference to where the congruent sides are, okay? The angles are always going to be across from your two congruent sides, okay? So we have to understand the idea of being across from, okay? Across or opposite, okay? Two things are opposite when they have nothing to do with each other, okay? So AC, the side AC, let me clear it out to make it easier for you guys to see, okay? The side AC, it has two angles that touch it. What two angles touch AC? Harrison?
1 and 3.
1 and 3, right? What angle doesn't touch AC? 2 is opposite that side, okay? Same thing with CB, right? What two angles touch CB? Right. Which one doesn't? Angle 1. Angle 1 is opposite that side. Do you guys understand that? Okay. So as a theorem, I'm going to still write it as a conditional statement. If a triangle has two congruent sides, two congruent angles. Okay? But specifically, they are across from the two congruent sides. So I'm going to say that it has two congruent angles across the congruent sides. Good? Okay. So let's shift gears to the converse of the isosceles triangle theorem. You know what converse statements do. They switch the order of your conditional statement. You tell me what the converse statement is then. Gabe.
If a triangle has two congruent angles, then it has two congruent sides.
Yep, that's it. Okay? If a triangle has two congruent angles, then the two sides across from them are also congruent. Okay? So if I told you angle 1 is congruent to angle 2, you immediately know that DF has to be congruent to DE. Okay, so you could go ahead and flip it over. Actually, right now, I want to skip to kind of that middle section where you're looking at number 5. I want to skip down to number 5 for a second. Okay? It says to find the measure of angle ABC, and they give you this diagram. So what's the measure of angle ABC? Yeah, it's 60, right? Because what I just found out is that if I have two congruent sides, the angles across from them are congruent. So that means that that has to be 60, which means what kind of triangle is this? It has to be an equilateral, right? Because that's got to be 60, 60. That's got to be 60. That's got to be congruent. Equilateral, equiangular. Okay, I want to shift over to number 6. They're asking for the measure of angle EDF. Okay, what do you got for me? Maybe I should label it. You're looking for this angle over here. What do you know about angle D and angle F? Gabe?
That they would have to equal 1.
Well, just in general, they're congruent, right? Because they're across from your two congruent sides. Everybody sees that? What do you know about the interior angles of a triangle? That's right. You can now account for 40 of those degrees, which means you got to figure out where the other 140 goes. Well, what do you know about that 140? Caroline?
Well, each angle could be 70 degrees.
It's split in half between those two congruent angles. So 70 and 70 here. Make sense? Okay. I want you guys to go ahead and work on 7 and 8. A little bit of algebra there, but that's a strong point for most of you, okay? So go ahead and try 7 and 8, and then we're going to come we'll go over those, and I want to go back to 1 through 4 on the board because I think they're tough.